Hello class, in this video we're going to be looking at interpolation and extrapolation. The learning intention of this video is for us to learn how to make predictions from the line of best fit and for us to consider the reliability of the estimated value from the equation of a line of best fit. When we have both a scatter plot and a line of best fit, we could use this to predict what values could lie in between or beyond the range of a dataset. Hence, there are two types of predictions. The prefix inter, like in the word inter-school sports, means in between, and interpolation involves finding what is the predicted value of a point that lies within or between the lowest and the highest values of a dataset. So if you look in the example down below, if you wanted to find out what was the sales given that the temperature was 21 degrees, this is an example of interpolation because the temperature is in between the lowest and the highest value. So it's contained within this section of the original dataset. In contrast, the word extra means beyond, like in the word extraordinary. Extrapolation is where we're trying to predict values that lie outside or beyond the range of a dataset. For example, if you were to predict what was the sales given that the temperature was 29 degrees, notice that this value over here, 29 degrees, lies outside of the range of a dataset. So that's what it means by extrapolation. When we're making predictions via interpolation or extrapolation, this can be completed by one of the following ways. We could do this by either eyeballing from the line of best fit to determine what type of value that's going to be. So for instance, if we're trying to find out what is the wind speed when the altitude is 5,000 meters, what you could do is you could therefore line up this value over here. And if you do that, you can see that that value lines up with 25 as the wind speed. So that's one of the methods that we could actually use to estimate the values. Another way that we could predict values is by using the equation of a line of best fit. So in using this method, what we do is we essentially substitute the values and then we need to solve for what that value is going to be. So in this example over here, since we're trying to find out what is the wind speed, we could substitute the height being 5,000 into the equation. And if you do this, your answer is going to be equal to 24.75 meters per second. As you can see with this example, the predicted value using each method differed from one another. The eyeballing method is not as accurate as it is subjective and relies on an individual's perception, whereas the second method is a lot more accurate as it involves calculations. For the purposes of this video, we'll be using the second method to make predictions. The next thing that I'd like to talk about is the reliability of our estimated values. As I've mentioned earlier, there are two methods to make predictions, interpolation and extrapolation. What I have here on the right hand side is an illustration that demonstrates what interpolation looks like, as it involves predicting values that is contained within the original dataset. As you can see by the scatter plot, you can see a clear positive linear association between the number of chirps and temperature. As a result, making predictions via interpolation will be accurate, as you can be pretty confident that the values within the range should also follow this linear relationship. In contrast, extrapolation involves estimating values that are found beyond the dataset. Compared to interpolation, extrapolation is not a reliable method because it assumes that data values found outside of the dataset also follows the same general linear trend that was found within the original dataset, which may not be the case at all. Let me use an example to demonstrate what I mean by this. Let's say we are predicting what is the number of cricket chirps if the temperature was 40 degrees. In this example, I'm going to use the eyeballing method so you can clearly see why this method is inaccurate. According to the line of best fit, I would say that the number of cricket chirps will be roughly 8 at 40 degrees. However, this method is only valid assuming that the values between 0 and 18 over here also follows the same linear trend. In reality, between 0 and 18, it does not actually follow this linear trend and it's actually non-linear, as you can see over here. As a result, if we were to do our estimations again, you can see that the answer is now different, therefore demonstrating the inaccuracies with extrapolation. So as you can see here, it's now equal to, let's say, 11 or 12 as opposed to 8. Let's now look at an example of extrapolation and interpolation. So in this example over here, they've given us the equation which relates weight and height for a number of students between 163 centimeters to 190 centimeters. Using this equation, it wants us to predict the weight of a student with the following heights, and it also wants us to identify whether this is an example of interpolation or extrapolation. So what I'm going to do is I'm going to substitute our height into the equation. So if I substitute 170 in, and put this into my CAS calculator, I'm going to get an answer of 62 kilograms. Since 170 centimeters lies within the original dataset, this is going to be an example of interpolation. Similarly, I'm going to do the exact same thing for part B, so I'm going to substitute 65 centimeters in. If I do this, I'm going to get an answer of negative 1 kilograms. 65 centimeters lies outside of the original dataset. As a result, this is going to be an example of extrapolation, and as you can see, this is not going to be a very accurate answer because you can't have a negative weight. It's time for us to check for our understanding, so I would now like you to answer the following question. Identify whether this is an example of extrapolation or interpolation. In this example, because we're trying to estimate what is the heart rate when you're 80 years old, 80 years old lies outside of the original dataset. As a result, this is going to be an example of extrapolation. In the next question, identify whether the following statement is true or false. In this example, the answer is going to be false because extrapolation is generally not a reliable method. And for the final question, use the equation for the line of best fit to identify what is the predicted value. So what we're going to do is we're going to substitute 600 into the equation. 0.1 times 600 is 60, so 40 plus 60 is going to be equal to 100, hence C is going to be the answer. What I'd like you to do now is I'd like you to please answer all questions from exercise 7G to get further practice. This is the end of the video. Thank you for watching, and I'll see you guys again in the next one. Bye.